Hi everyone, this is Kevamshi from ECT section. So having roll number 04M7. So today I want to discuss about the high-speed printed circuit boards under the subject electronic devices and circuits. So let's get into the topic. First, what is PCB? Means PCBs are a backbone of electronic device or electrical devices. They are non-conductive boards that holds all electronic components through a circuit embedded over it. So this is a board where required components of a circuit are built on it, and it is a non-conductive thing. And PCBs are built to last for a wide range of industrial and commercial and domestic applications. So these are used in industrial, commercial, and domestic appliances. So they can be customized to any specification to our user requirements. So we can modify or customize for according to the user requirement and our requirements. So they were first made during the Second World War to use in capacitors and transformers. So these are having types as single sided, double sided, or multi layer. So this can be classified as a single sided PCBs and double sided PCBs and moreover multi layered PCBs. So in the PCBs, it have a parts like the assembly consists of following parts like components, actual devices in the board, and PCB components can be categorized as active and passive. Coming to active components include diode which allows current to flow in one direction, and transistor amplifies and switches electrical power and electronic signals, and integrated circuits DC means responsible for several signal processing functions. So coming to the passive components included in PCBs are capacitors like it stores and discharging electricity, and resistor limits the power of electrical current, and inductor means responsible for creating magnetic fields. So every component on PCB has defined work to do, uh, which all gives our required or customized product for the appliances. So we can you can see these four material used in PCB PCB design like substrate material, conductor material, adhesive materials, and protective coating. So but where we use we use in military purposes and aerospace, medical, and telecommunication like mobiles. Medical means like in like some surgery machines, and automotive like manufacturing, and consumer appliances like a mobile charger or something else. So these are the uh, domains where we and these and many more where we use these PCBs for our work. So coming to our main topic, high speed PCB design or high speed boards, PCB boards. Like high speed PCB design is any design where the integrity of your signal starts to be affected by the physical characteristics of your circuit board, like your layout, packaging, layer stack up, interconnections, so etc. Designing a simple board where most of us focus the time is on component placement and routing, but with a high speed design, it becomes more important to consider exactly where you are placing your traces, uh, what width they are going to be, and how close they are placed in other signals, and what kind of component they are connected. So uh, high speed uh, high speed PCB can have some complexities like it defined to work as a high speed by how they are placing, and what type of components we are using, and what is the power, and what is the capacities, and everything defines the high speed PCB. So for but there are three more big problems in designing of high speed PCB design, having like timing, mean integrity, noise, but these can be overcome uh, according to the time, like using impedance, like matching and spacing. So timing and integrity and noise are reduced or totally evacuated by using impedance and matching and spacing. So these are main problems considered ago for designing of high speed PCB design. So in the for the market convergence of PCB design, these are here you can see the left side diagram shows the consumer, computing, communications and multimedia, where for the marketing convergence, and for the design convergence we use as a hardware and software, digital analog and IC and board. So ICs and board. So these are different domains where we use these high speed boards according to their convenience or convergence. So here you can see the use or 11 practices for the high speed PCB, like route high speed signals over a solid ground plane, avoid odd spots by placing wires in grid, keep trace bends at 135 instead of 90, avoid acute angles, increasing the spacing between traces to avoid crosstalk, avoid long subtraces by implementing daisy chain routing. Do not place any components or between differential pairs. Incorporate length matching to avoid skew between differential pairs. Do not route signal over a split plane or separate analog and digital ground planes to reduce noise. Split the layouts virtually between analog and digital grounds and keep race width as per the size of discrete components. So these are the 11 practices we have to consider while designing the high speed PCB to be work and efficient for our requirement project. So I think you have understand about the design and what to do consider while designing the high speed boards. So thank you.